So here we're going to be talking about density. Density is an intensive physical property that relates the ratio of mass to volume. Remember that an intensive property means that the density of a substance is always the same, no matter how much of the substance you have. It's a constant ratio. It is a constant ratio. So the density of water is always 1 gram per milliliter, whether you have a lake full of water or a single drop of water. Its mass and volume are always going to have that same ratio. The units for density are typically in grams per milliliter or grams per cubic centimeter. Density can be used to help identify a substance since it is an intensive property. If you have a substance that you don't know what it is, but you can measure and calculate its density, you can look at a chart of densities and see if you can find something that matches the thing that you have, and that could help you narrow down what your object is. An object will float if its density is less than the density of the fluid it is placed in. So the density of water is 1 gram per milliliter. For every gram of water you have, it will take up 1 milliliter of space. That's what this is saying. Objects with a density less than 1 gram per milliliter will float in water. At this point, I do want to point something out. These little slashes right here, that means per. Like miles per hour, the same kind of per. This is grams per milliliter, grams per cubic centimeter. Out loud, please use the word per. Don't say slash. Don't say grams slash milliliters. Don't say grams slash cubic centimeters. Say grams per milliliters, grams per cubic centimeters. Okay. When you have something where the particles are very spread out, there's going to be a low density. When you have more particles closer together, the more particles you add and the closer together they get, the higher your density is. So we could say that the stuff on this end is probably a gas, and by the time we get to this end, your higher density stuff is going to be solids, where you have a lot of things very close together, so you have a lot of mass for each amount of volume. That's going to be a higher density. That's more likely to be solid. And then, of course, anything in the middle could be a liquid. So if we look at some solids like butter, ice, aluminum, copper, gold, the densities of these are pretty, whatever, 0.86, 0.92, 2.7. Compare that to these liquid densities. Most of these liquid densities are smaller numbers than most of these solid densities. Gasoline is not as dense as butter. Sunflower oil is actually the same density as ice, but like liquid water, milk, those are not as dense as aluminum and copper. Mercury is an extremely dense liquid. It's one of the densest liquids there is, and that's actually really rare, but it's still less dense than something like gold. But look at your gases. The densities of these gases are extremely small numbers. 0.00018, that's a very small number, and your gas densities are always going to be very small because you have a small amount of mass spread out into a large amount of volume. So a high density means that you have a large amount of mass in a small volume. Think about like a block of solid metal. It's going to feel really heavy in your hand even if it's a small block, and that's because there's a large amount of mass and a small amount of volume. But a low density, you have a small mass in a large volume, so it's going to feel really light even if the object's really big. Think of a balloon. A balloon can be easily, the size of like a basketball or bigger, and it's still going to be very light because it's going to have a low density. There's not much mass there, but it's taking up a lot of space. So this asks, what is the density of a block of marble that occupies 287 cubic centimeters and has a mass of 869 grams? Well, to answer this question, we're going to need the density formula, which is right here. Density is mass divided by volume. Remember that this fraction bar tells you to divide. Density is mass divided by volume. So what we're going to do, and we can abbreviate that formula, we can just write D equals M over V. If they ask what is the density, well, I know density is D equals M over V, and they tell me it occupies 287 cubic centimeters, it has a mass of 869 grams. 869 grams, they're telling me that that's a mass, so this is going to be my M. And in general, mass is always going to be grams. You should know from your math classes, if not also your science classes, that cubic centimeters is a unit for volume. Anytime there's a cubed distance, that's always going to be a volume unit. You should already know what those units mean from your math classes. So here's an M, here's a V, they want a D. We're going to plug this M in here and substitute. We're going to plug this V in here and substitute. So what we're really doing is density equals the mass, 869 grams, divided by the volume, 287 cubic centimeters. And now you can just put this in your calculator. When I put that in my calculator, I get 3.02787, and then there's a bunch of other numbers. We're going to always round to the hundredths place. We're going to round to the hundredths place. That's 2 decimal places. So we're going to round to here. Okay, but this 7 tells me I should round up. So instead of 3.02, I'm going to round this to 3.03 for my final answer. And I need units on my final answer. Those units are this right here, grams over cubic centimeters, or grams per cubic centimeters. Remember that your units for density are always going to be grams per cubic centimeter or grams per milliliter, at least in this class. They can be other things, but in this class we're using one of these two. Since this problem didn't use milliliters, this problem used cubic centimeters, that's how I picked which ones were going to go in this density. Let's turn the page. I'm not going to do this entire page, but I'm going to do a couple others off of it. I want to specifically look at number 5 together. It says a cup of gold-colored metal beads was measured to have a mass of 425 grams. The volume of the beads was calculated to be 48 milliliters. Given the following densities, identify what kind of metal the beads are made of. So, first, if these are all densities, over here, these are all densities, then I need to know what the density of these beads are. So again, I'm going to use that same formula, density equals mass over volume. Again, they're telling me the mass is 425 grams, and they said the volume was 48 milliliters. So I'm going to plug those numbers in again. 425 grams over 48 milliliters. And if I stick this in my calculator, 425 divided by 48, I get we're rounding to the hundredths place again, so I'm going to round this to 8.85 grams per milliliter. Now, if this were gold, it would be 19.3 grams per milliliter. So even though they are gold-colored beads, they can't be gold because we got a density of 8.85. Gold is 19.3. So if we want to know which metal this is, we just need to look for one that has closest to the same density as the one I calculated. Since I got 8.85, this 8.86 is definitely looking way closer than any of the other numbers. So I'm going to pick B, copper, 8.86. And on number 6, it says a student has 1,500 milliliters of water. What is the mass of water in grams? And a hint that the numerical density of water is listed in your notes. So we definitely are going to need this density equation again. They tell us 1,500 milliliters. Milliliters measure volume. So when I go to plug my numbers in, that 1,500 milliliters is going to be on the bottom here. But we are looking for a mass. That means the mass is like our x this time. And we need to plug in a density. It says the density of water is in your notes, which it is right here. The density of water is 1 gram per milliliter. So this density, I'm going to plug in from my notes that the density of water is 1 gram per milliliter. That's what I'm going to plug in for density right here. So 1 gram per milliliter is my density. That's going to equal x, the mass I'm looking for, over 1,500 milliliters. So something divided by 1,500 equals 1. There are two ways you could do this. You could think about, well, anything divided by itself is the only way you're going to get 1. You could also take this out of the denominator by multiplying times the reciprocal. And then if you do it on one side, you have to do it on the other side. So this side ends up just being x, and the left side, 1,500 times 1 over 1, that's still 1,500. And we need units for this. My x was supposed to be a mass, so my units here are going to be grams.